Okay, so quick introduction to arithmetic sequences, and I will apologise in advance for any more cooking noises. So I did kind of tell you this before, but the terms increase, or they could be decreasing by a fixed amount. So, for instance, 3, 7, 11, 15 would be an arithmetic sequence. 17, 14, 11, 8 would be. So obviously that one we got plus 4. Plus 4, and here we've got minus 3. Minus 3, etc. We need a little bit of a formula for the nth term of an arithmetic sequence. The first term is denoted with A. For once the letters kind of make sense. The common difference is D. And the number of terms is n. So these are both infinite, so I put some dots on them, but for this one A is 3. D is 4, so the common difference, what's the difference between the second term and the first term? This one A is 17 and D is minus 3. And that will give you a decreasing sequence. And so the first term is equal to A. The second term is equal to A plus the common difference. The third term, we add the common difference on again, so you get A plus 2D. And so the nth term of an arithmetic sequence is given by A plus n minus 1D. So you need to know that. One thing to note, but I'll look at this with sigma notation with you as well, but n is a variable, so n is changing. A and D are constants, so this is actually a linear equation if you look at it, but we'll come back to that later. And that is your notation for the nth term. So that's a deductive definition. I'll just go over a couple of examples and give you something to do. It's quite an introduction to lots of things, sort of lesson today, I've realised as I've gone through. So, e.g., find the 15th term. Can you not do these in your head? So just get used to using the formulae. This bit of maths reminds me of the way you might work in physics, potentially a little bit, and that you have a set of equations which you have to apply and use. But you need to just get used to using the equations. So I admit you could probably go along your fingers and get to the answer as quickly as me, but yeah, if we could use the formulae, that'd be good. So A is 11. They will get a bit more complicated as we go through. D is minus 3. We want the 15th term, so we can set n equal to 15. And then remember, notation for the 15th term is u subscript 15. And that's equal to A plus n minus 1, which is 14. Times D. You need to, the only errors I see here are BIDMAS errors, and I mean that quite seriously. Your calculator follows BIDMAS to the T, so you could just whack that into a calculator, but obviously you need to do 11 minus 42 to get minus 31 And then let's just do one more. So we have an arithmetic sequence, and we want to know how many terms there are. You probably don't want to do this one in your head, it'll get a bit boring. So A is 11, D is 4, the nth term is 643, and so using our formula, so I'm using this, nth term is A plus n minus 1d. Then 643 is equal to 11 plus n minus 1 times d, which is 4. So subtracting 11 and dividing by 4, n minus 1 is equal to 158. N is a positive integer, so if you get a weird answer here, you've definitely made a mistake. And so n is the 159th. I was going to say 159th term. N is 159, so there's 159 terms in that sequence. So I'll just get you to do some of those, and then we'll kind of, yeah, make it a bit more complicated next lesson.